Evening, sir. Mic check, 1, 2.
Afternoon, guys. How are you?
Guys. Oh,
Afternoon, sir.
afternoon, sir.
Yeah. Trust me, I have a splitting headache. I'm just gonna put it out there from early. I have a splitting headache. Oh my goodness.
Well, go on, sir.
You know, and to be honest with you, I one of the few Saturdays when me get up and eat breakfast and me get up and literally prepare a meal because I had a class from 8 o'clock this morning, and while the students are work, me mute and me in the kitchen and me look out for breakfast and me eat my breakfast, drink the tea, drink all juice. I mean, I normally do. It hurt me.
Sir, you do too much things, sir.
God, those stuff.
You do too much
Eh?
things, sir. You do too much things. You prepare too well.
Trust me, buddy, trust me. Trust me. And other times when I don't do it, I'm perfectly fine. Like last week, me not eat nothing. And I was perfectly fine. No, today, John, no. Anyhow.
Sir, if I should tell you that I'm just having breakfast, would you believe me?
Well, this is common assault for me because at the time I brunch me eat, so me can't understand that brunch. Anyhow, how are feeling so far? Maurice, starting with you. How are you feeling so far, reading? And I want you to be honest with yourself. Rasheen, think about it because I'm going to ask you to also be very honest with me. How do you feel as it relates to the level of preparation for your exam? You'd have seen me send the draft timetable a while ago.
Yes, sir. All right. So, you finished, sir?
Yeah, man. Go ahead, Papa.
Yeah. So, all right. It's like more wondering if I have enough time to really absorb what I need to before the exam. Yeah, that are my main concern because, all right, you have the Saturday class is the 4 hours, and you're sure what is what. And then I personally go up on EducoSoft and I try go through the things there more. But when I realize though, well, I still don't try a budget assignment yet,
So I realized. I see you reading the tutorials because I see evidence of the tutorials being read because your footprints are left on EducoSoft every time you go onto Educo.
Yeah.
So I can see that. So I see that you're doing this stuff, but I'm not seeing any assessments at all from anybody moving on.
Sir, for me personally, it's like more go through the whole unit 1 by EducoSoft first before me really like absorb a good amount before me start the assessment. And I'm trying to do that. But it's like me I wonder maybe we might have to go skip out certain things or something just because of the time. Yeah. So, my main concern at the time, I just wondering how am I gonna get everything, get all the profits done.
Well, the truth is, you need to just pace yourself, because based on what I am doing, I am going through the areas that I know are very critical, important areas, so to speak. So I was hoping that people that start do the assessment so we can see what I keep. But the assessments them now move the way me want the assessment to move.
Boy. Well, for me, sir, I can chime in quick. I'll be honest. And I think we should take on the fast track my summer here because I am busy on a Saturday, and I thought that the fast track would have been sometime in the week. My
Mm-hmm.
Saturdays are really cramped because if you realize, until last week Saturday, so I'm at the doctor with my girlfriend, right?
Mm-hmm.
Little after that, we had lunch, and after we had lunch, I have to carry my father-in-law to the doctor as well, go for you, and we never leave you until after 11. So my Saturdays and summertime it's very hectic. Even the other Saturday when I had to for my grandmother's funeral, and then I don't remember what we were supposed. I think we didn't have class one Saturday, but even
Yeah.
that day I was busy as well. So
Mm-hmm.
I really don't know. I mean, I do understand some of the work that is given. I haven't touched Edica staff as yet because work has been a bit demanding, but I'm trying. I'm trying because I have a day off Monday.
Mm-hmm.
Um, I have sometime today and tomorrow, so let me try see what I can do.
All right. Now hear me out. And I know I'm being recorded, and the other students will hear this, but I mean, it is just a truth, and I can only speak the truth. So Maurice um, was having a conversation, an email conversation with Mrs. Campbell. Mrs. Campbell and Maurice came up with an idea because Maurice needs this to complete his course of study. Mrs. Campbell touched base with me, and based on the proposal, I don't think I would trust him all too well just to be self-directed, which is one of the things that was being recommended. And then I remember you, Rashim, that you need to finish off this season with this. And then I said, Mrs. Campbell, what I don't want to happen is I have my students in the system and they have a math course outstanding. It is because of the math course why they can't finish. Let me do a fast track class. She said, okay, great. I said, please to coordinate it. She said, no problem. I honestly thought that the fast track class would have been in the evening. I teach Monday, Wednesday. Yeah, Monday, Wednesday. So I thought it would have been like somewhere um, Wednesday, Tuesday, Thursday, Friday. But based on the thing, when I asked Maurice, since he was the first one, he would have had, he is available Monday 7 to 9, but I have a class 7 to 9. He would have been available Wednesday 5 to 7, but I have a class 5 to 7. Sorry, Maurice?
Sorry. Yes, sir. Yes, sir.
Right. So we recognize that the times in the week wasn't syncing up with everybody else. So unfortunately, I had to put the class in on a Saturday at this time. Now let me just be very frank and honest with you. A Saturday at this time is when I would have my little downtime after teaching my 8 o'clock to 12 o'clock class. Because for the past couple of years I have been doing some weekend classes. So when I finish, I literally have a 1 hour break, 12 to 1, to come back in up to 5 o'clock, which is very rough. It's very rough. um, I was sidelined for it. How could you take on a class like this at this time? What if you're going to the supermarket? You can't go because of that. And I said, yes, I agree and I understand. But in my headspace, I know I had these 2 students who needed to finish off the stuff. So why am I saying all of this? So to hear the 2 students who propelled me in putting this class in place are now saying to me, sorry, Tete, when you can make me have to go back to my wife and say, sir, the 2 students who never did pass the course because whatever the situation, she going to laugh me to, she going to have my neck for it. She's going to have my neck for it.
Sir, hold on.
Yes,
You
please,
know,
I'm calling. I am holding on. Maurice, tell me that you tell me, Maurice, before you even start, Maurice, tell me that you're going to say to me, sir, I didn't tell you that I'm going to fail the course. Please tell me that you're going to say, Maurice, please.
Exactly.
Okay,
What I
Maurice,
mean to
just
say is
I want
that
to
me no
hear.
plan for back down, sir.
Maurice, Maurice,
Likewise.
Maurice, Rashim, I don't know if he here and I say, Alton, come on, but Maurice, Rashim, that's I tell you what I tell. I know what I tell is being recorded, and that's what I tell you. I know the conversation first started with you, Maurice, and I said,
Yes, sir.
"Oh, Jesus, Mrs. Campbell, no, I don't feel comfortable for him just doing that alone because that and Mrs. Campbell, I don't have the time." And then I thought about it, and then Rashim and I would have had conversations before, and I said, "You know what, Rashim did it to you, man." And then I said, "Okay, fine." There are other students. I said, "Okay, here, plan, Mrs. Campbell. Let us put in the stuff." So it's a sacrifice for you, I know. It is also a sacrifice for me. Like right about now, let me tell you what I don't want to do. Go lay down and fall asleep. Me not real, especially after teaching a class this morning and getting worked up on the whole stuff. The real thing is for me to just go fall asleep. But I have made a commitment, and my commitment is to see you guys through. But when I look at it, I'm very concerned because when I go to Edicosop, it's just a few of you, what, 6 of you? And when I go to Edicosop and I look at Edicosop, I don't see no movement. Matter of fact, one student says, "Sir, I don't think I can go through again." Whatever the situation is, and I just want to know that we're going to commit to this, because if I don't want to sound callous, but I understand that we are fighting against many variables, and it can be a distraction, but when I have to tell me, we have to come up with an agreement. What I did was to reduce the number of pieces on Edico with the expectation that by now we'll see some little movement. Not at all. And I'm saying to myself, okay, where did I go wrong? Should I have said, "Mrs. Campbell, I'm unavailable," or did I do the right thing? I know you guys want to finish off, but you don't have to commit to this. I know it's rough, but you have to say, "Here the plan." I'm going to sit up. I'm going to lose little sleep. I go and Rashid, I understand when sickness take you, it take you in the wee hours a night. It take you when you don't have no money. It take you when you don't have no gas in the car. It just don't ask permission. It just come at you.
Just come like a flood.
Yes, man. But we also have this to do, that we have to send some energies to it. So you tell me. I hear what Maurice say. Sir, me never say. Me never feel it, But at this point in time, I need to see evidence of movements, so I know we're getting somewhere. Because there are other areas that I don't go through yet. There are other areas that I've not yet gone through. I would have loved to be further than where I'm at now, but I'm not getting the traction at all. People don't come out to the class. People come out to the class late. La-di-da, la-di-di, it. So I'm wondering if I should just say, "Boy, the plan. Call it a day," or I get the commitment, so, "Boy, we're gonna do this and we're gonna stick to it." I don't know. So I get in suggestions. Alton, what do you say? How committed are you?
I'm very certain.
Never.
Yes, because I want to get it out of the way this semester. Really want to get it out of the way.
Yeah, me wanting to get it out of the way, but it means that you have to go online. It means that you have to complete your work. Go online and read the tutorials. Go online and answer your and answer your assessments.
I'm still awaiting. I'm still awaiting access to that, sir.
Oh, you don't have access to Edico? I just realized a while ago. Okay, hold on. Don't even move a foot further.
Check it, still have access.
No, you don't move a foot further. I don't like how I'm feeling, you know. I think my body's tired, so because of that, I'm susceptible. All right. So I did make a mistake, and she did a lot of work between now and then. I have a student who has completed all the pieces on Edico now. And if the student can complete all the pieces on Edico, I expect the rest of you to do the same. You really want them to do the work. So what I'm seeing just now, as I've logged on.
Sir, hold on, before I go any further, right? The
Mm,
assignments on Educa, so. Because my fear, you know, well, before I go there, so. If we need to, can we do over assignments?
you know,
That is one of the reasons why me personally
Maurice.
on it, you know.
You know, every school year, I I have one of you in the class. What do I mean by that? Uno worry on yourself unnecessarily. Jesus, Father, uno worry on yourself unnecessarily. Me say start this thing. Don't worry about if it don't do good. Start this something. Let me see what it is that you're doing.
All right, sir.
Every semester, I have at least one of you guys. No, man, get going. Get going, get going. Alton, what's the last two digits again, please? For your email.
25.
All right. Trying to get you sorted out now. Check now for me, please, Alton.
Sir, it's still the same course, not assigned.
No, man. Alton. And that's ALTON.JAMES 25.
Yes, sir.
Can you press F5 for me, please?
All right, let me try that. Nothing new. Same.
Just telling you the same thing.
Yes, sir.
Are you doing more than one math courses?
No, sir. Just calculus too.
alton.james25 at my.ecc.edu.jm, but you're there. Matter of fact, you tried logging on at 1:39. This is missing to me that you. I'm gonna look at the detail. Yeah, you're using Google Chrome. You just log on with using Chrome a while ago, browser?
Yes, sir. Yes, sir.
Yeah, that's what it's saying to me. So I don't know what happened, but you are. All right, do me a favor. Share your screen. Let me see something, please.
Remind me, you share screen again, please.
Go to the bottom of the toolbar and you see that green thing that says with an arrow.
Oh, sorry. Yes, sorry.
Mm-hmm. All right. Go to home for me, please.
Home?
Yeah, in that the first thing in the orange bar. All right. Click on home. Click on course tools for me. Click on assessments. Log out for me, please. Log back in now. My head hurts, man. No, man. You mean Alton is at the back.
It?
I'm saying your Alton is at the back.
Sir, but that weird. Him still get for login even though the email is incorrect.
That's what I'm saying. I wonder.
Yeah, that weird.
Because what would have happened is that maybe there's an incorrect. All right, do me a favor. Go into the search bar. You see that box? He may have had that incorrect access to Educasoft. That's like showing blank. So the corrected one supposed to have the correct thing. Go to course tools for me now. Course tools and an assessment for me.
Okay.
So when you were being set up at some point in time, are you an original Excelsior student?
Yes, sir.
Right. So at some point in time in some of the other courses that you were registered in, somebody made an error with your name, and it would have been you have been registered on the system with that incorrect stuff. So I would have corrected it. So this is a corrected one that you're supposed to be using.
All right, sir. That's much.
No problem. You can stop share. Top icon after the green, you should have orange. Stop share. Yeah, no. Look, right. Good job. Yeah. So what I want from you guys, as I said before, there's a student who completed everything already. What I want from you guys is a commitment. Find the time. Find the time. I know it's difficult, I don't want anybody to think that, boy, so I thought like him not understand the strips. I know it's difficult. But guess what? You have to go find the time, students. I've committed myself. I could have said no. I could have said, Mrs. Campbell, I'm unavailable. I could have said no. But I decided to
Sir,
come.
I appreciate say you never say no, sir.
Yeah, but you see, but the thing about it, Maurice, is that the greatest appreciation is for me to see the work going on, for me to know, say, boy, yeah, man, them students are really at work. I mean, I see the evidence yet. So I'm going to wait until next week still, I see like one Monday come on holiday. I mean, I want nobody say, sir, I have to work on the holiday. I mean, I want to hear them something, I want you to find some time for yourself, on to sit down and on to complete work on the platform. Very, very important. Have a promise yourself first, and then you can promise me after. But the work must be done. If the work not done, we can't help And I should tell you, like I told my class this morning, when is the calculus 2 scheduled for? Which day? Anybody looked at it?
I think I see September the 5th.
September the 5th. Rock store. When exams start?
When say a while ago, Maurice? September 5th?
Yeah, I remember seeing. I gotta check it again still.
Alright, that means a good thing, that man. Good thing for me. Good thing for me. Me have time. Yeah. Because I think me have some days in September and it start on the 5th. So Maurice, I know morning at the exam or the evening.
It's only the first draft,
First draft?
It's only the first draft that I sent.
More than likely it might not change.
Alright, so far it's in the morning.
More than likely it might not change, sir.
When the exam start, Maurice, look at the time when the exam start.
Sir. August 29.
Okay.
Oh, so the 5th of August is a Monday. The 5th of September is a Monday.
Yeah.
I know I'm going to be back at school them times here. I'm going to be back at school, meetings, planning meetings, this or that, timetables, and the whole
sorry. If we're going to be keeping classes close to that time.
If you're going to what?
You'll be keeping classes close to that time. Or are you going to stop when the semester?
No man, it's because remember we started late, Remember we never started the same time like the other people?
Yeah.
So more than likely we're not gonna have no class next week Saturday because it's holiday. But we'll have class the 13th, we'll have class the 20th, and I am thinking that we're gonna have class on the 27th.
So sir, if it is that we don't have class next week Saturday, we can squeeze something probably Friday evening.
I don't have a problem with that. I mean, you let me know. I mean, to be honest with you, my Fridays are free now, so I can squeeze in something on a Friday. But I think when I made that suggestion, some people said they had another class.
I have 3 classes on Friday. So
I remember that.
What could I use the Friday for do is like probably catch up back from what we do the Saturday before, instead of we'll go do something new and then person it out.
But sir, we couldn't still have a Saturday class.
The truth is, we could. I'm not going to be able to get access to the Excelsior's Zoom. That's one, because I'm not sending out any, and we have to use a 40-minute something. That can be I find that to be a little distracting because sometimes when we set it as recurring, some people don't come back. But we
Google
can.
Meet, you know, sir.
Huh?
Google Meet.
Yeah, I was just
Yeah,
about to
Google
suggest
Meet.
that. Google Meet.
Yeah, to be honest with you, my rather use the 40 minutes with Zoom. The Google Meet for me don't work all too well. I mean, I know how to use it, but when we get closer to that, we can discuss that sometime in the week about the Saturday classes. I mean, the next week's arrangement. All right. So I forget the commitment from you guys that this is it. That we're going to be doing what it is that we ought to be doing. What it is that we ought to be doing is focusing a little bit more on completing our task at hand. And our task at hand is the assessments, quizzes. We need to talk about our mid-semester, etc., this and that and Tara knows what. So all of those things are things that we need to talk about. And more than just talk about, but to put into practice. All right. So last class we looked at some little rules of refresh our memories on the rules of differentiation. We looked at some more, what do you call them now? Maclaren's expansion. And today, I am thinking that we should move from our unit 1 that we're still in to look at some other areas. And in particular, I want to look at applications to or integration. And our integration would be Taylor's expansion in particular. So it's what I'm doing. I'm actually going through the areas that I know are going to be extremely critical. I know the other areas are critical too, but these areas are the areas that give you the big points. I'm going through those big points area first. And then we can look at those other little areas that will come up. All right, so having gone through those, the recordings are there, and as a matter of fact, as I said before, you have access to all the other recordings on Calculus 2 that I have in the channel. It's one of the reasons I keep it. So I'm going to ask that you hold on to those to dear life. Go through those. I won't even do that with you now. I won't even do that with you. Go through those for me, please. Very important. Go through those. Trapezoidal. All right, let me go here. All right, so I pray that you will try to be as focused as you possibly can. Now, as I go through the trapezoidal rule with you, this one is also a must-have. There is no way you'll be able to go through this without looking at the trapezoidal. This one is a must-have. All right, so I try to find something to next. So let's go. Trapezoidal. So what I'm saying to you that this is a technique is much more accurate way to approximate the area beneath a curve. So when I give you a function to integrate a definite function, and I say integrate, so forth and so on, it means that I'd ask you to use one of the rules of integration in order to solve the question. Now, I'm teaching you an application to integration where you're going to be looking at an alternative method to integrate a function. So you're going to be constructing some trapezoids. You're going to be constructing some trapezoids. You're going to be marking the height of the function at the beginning and the end of the width interval. Then you're going to connect the points. This method is going to require you memorizing a formula. It's going to require you memorizing a formula. So let's just have the conversation. Let the function be continuous over a closed interval a, comma, b. Therefore, the trapezoidal rule for approximating the integral of this function, look at the function. The function is f of x dx, and it gives you the upper limit b and the lower limit a. Upper limit b, the lower limit a. This is my function. I can go ahead and apply any of the rules of integration toward that. This in particular is asking me to use a trapezoidal rule. Here goes the formula. This function outside here, so in red, if you look at it up here, is the exact function right up here, so in black. But look at what the function says, the rule says, the law. It says delta x, which is a change in x over 2, is going to be multiplied by f of x of 0 plus 2 times f of x of 1 plus 2 times f of x of 2 plus 2 times f of x of 3, so forth and so on, until you reach the last one, f of x of n. Sir, I don't understand one thing where you just read. Not a problem. Delta x is going to be b minus a over n. B minus a is your upper limit minus your lower limit divided by the number of trapezoids that you want. Your upper limit minus your lower limit divided by the number of trapezoids that you're interested in having. It says the area of any trapezoid is half the sum of the parallel sides multiplied by the perpendicular height. So from C-set mathematics, you know that's the formula for calculate the area of a trapezoid or the area of a trapezium. Half the sum of the parallel sides times the perpendicular height. Same concept is taken across here. The bases are the parallel sides. The bases are the parallel sides. So the area of a trapezoid is half the sum of the parallel sides multiplied by the perpendicular height. the bases are the perpendicular sides. Now recall the formula, a half AB times H. In the 6 maths paper, take up and look at the formula sheet. One of the first set of formulas you'll see on the algebra is this, a half AB times H. A half A plus B times H. Now, there's something I need to point out to you. Let us look back at the formula. The first one in blue, the last one in blue are the only two terms. That is not being affected by the multiplication of a 2. Say 2 here, so. Say 2 here, so. Say 2 here, so. And say 2 here, so. The first term and the last term are the only two terms in the formula that's not going to be multiplied by 2. Why, sir? In the trapezoidal rule, every base is used twice for consecutive trapezoids. Every base is used twice for consecutive trapezoids. Let me ask you a question. Anybody report more in this class?
No, sir.
Harborview, Glendale? No? All right. Anybody know what it means by two houses and each on each other?
Yes, sir.
Yes, sir. I've seen them.
All right, good. Now, when you look on the side of the house, where each on, you see? Because the side of the house where each on, how many times do you think that piece of something going to be counted? I can answer quickly and say 2 times. Because resident of A has that wall right there. Resident of B also have that wall. So the side that is being shared will be counted twice. Why twice, sir? Because resident A is going to count it. Resident B is also going to count it. But the other 3 sides of each house will only be counted once. Tell me if you see what I'm talking about.
Yes, sir. That's what you're saying.
Why the side of that is being occupied by both counted twice? Because a resident of A is going to have that in their count, and the resident of B will also have that in their count. So both residents, because they are sharing that boundary, will end up counting it. That boundary will be counted twice. That boundary will be counted twice. Talk to me.
Yeah, I think I'm following what you're saying.
All right. I don't want you to think. I want you to get it. I want you to get it. All right.
I get it, and the same principle would apply for like townhouse. We have like 4 or 5 units attached down the line.
Yeah. So each side of the townhouse, the 2 residents then are gonna share the side where join on each other, don't?
Yes, sir.
So that side I gonna get counted twice because it a share two smarty. Put it this way. Let us look at a parking spot in Jamaica. And Lord have mercy. It's the first time me go foreign many years ago. And me go a road and me look on them parking spot. He said, Jesus and peas. In Jamaica, 2 car can park right here, so. Then parking spot generous till our parking spot, it tight. When we can get 10 parking spots out of it, America get 5. America is getting 5. Sometimes you're in a parking spot and can't even open the door. Talk truth.
Yes, sir. Enough time.
And some parking spot, Maurice, I don't take it me now because I know so when they open them car door, they go swing it. And they no business. So some parking spots I just don't take at all. Or I don't think this is I drive a car and drive, that's fine. That is perfectly fine. Because I'm sure you put me on the road against you can't hold me. That is perfectly fine. But what I don't want is that you go take a car and swing and lick and dent my car and creep up my car and mash up my car. So I will park under the big tree and pray so not no drop down on it, so that I know that nobody is going to come and swing them car door open or try to pass between the side mirrors and you use your body to brace back or to break off my stuff. Right? So the sensors no longer work. Alright? So when you look at the parking spot that is marked out, each line of the parking spot, I want you to envision something for me. Think about something for me. In the parking spot beside library on campus, and you have the walkway on either side. Think of you having that straight line of parking when you're walking down. Each line in the parking spot is going to be used twice, with the exception of which 2 lines.
Repeat that, sir.
All right. You have 5 youths stand up beside each other, and it don't have to be 5 youths. It can be a male, a female, a male, a female, a male, a female. Because if you say you don't want no male to touch your hand, that's fine. That's not the conversation. So you have 5 humans, 5 smarties stand up beside each other. Stand up to the point where the length of their arm is touching each other. So they're standing side by side. The whole length of the arm is to the arm is resting on their side. So is the other person. But the person is so close to you that both arm lengths are touching each other. Everybody can envision that?
Yes, sir.
And I have 5 people. I have 5 people in the line. And I'm using 5 in particular because you have 5 fingers on each hand. So I want you to put up the palm of one hand. Let me make it easier. And put 4. So you can put your thumb in the palm. I just have your index, middle ring, and pinky winky up. All right. Each finger is representing a person, Each arm of the 4 individuals will be touching another arm with the exception That's the problem I have with you now, you know. When you talk to me, no, man, it's I don't know it, I don't know it, but just talk to me now.
Sir, you drop out a while ago, you
So
know.
you got silent a while ago.
I stopped. I stopped talking because I asked a question.
No, sir, before
You
you
can
finish.
never complete the question, sir.
Oh, I never complete the question.
No.
Okay, all right. I apologize. I don't know what is happening with digital, you know. That very thing happened to me, but it says strong. That very thing happened to me this morning. All right, let me go again. All right, so here the instruction again. So you have your 4 fingers up. Each finger is representing a person. Each person has 2 arms. And I'm saying to you, each person is touching each person's arm is touching another person's arm, with the exception of how many people?
2, sir.
Which 2?
The 2
The 2 at the ends.
Okay, all right. Want to see it? That's why, you know, the formula, the 2 on them at the end, no, I'm not 2 because only 1 arm I touch. But the 1 here, I touch this arm and that arm. The 1 here, I touch this and that, so forth and so on. So that's why I have a 2 in front of everything else, with the exception of the first one and the last one. I saw you tell me a while ago now, talk truth.
Yes, sir.
All right. I hear that answer, Maurice, and I'm not too convinced that you follow me.
No, man, I follow you, no.
All right, good. So that's the point I'm making. The point I'm making is each person will be touching another person's arm. The first one is only going to be touching 1 arm. But the person in the second position, both arms will be touched. The third position, both arms will be touched, so forth and so on, until I get to the last person. The last person will only be touching 1 arm. And that's why in this formulation, you have the first one here without, and that's why I put them in blue. You don't have no 2 in front of that, because that's just 1. But the second, third, fourth, as many of them in the middle as possible, both sets of arms will be touched. The last one not gonna have 2 arms touching either, they'll just have 1 arm touching. And that's why we have a formulation like this. So it's just 2 of x2, f of x2, plus 3 of f of x3, plus 2 times f, sorry, let me go again. 2 times f of x1, plus 2 times f of x2, plus 2 times f of x3, and plus 2 times f of x to the n, see it here, so, minus 1. And then now the f of x to the n is when it is the last one. So the last one and the first one is not going to be affected by that sum. So this is what we're talking about. This first one here don't have nothing. So these are my trapezoid. This first one don't have nothing to touch. But the one here, I have the one over here and I touch the one here, so. So the one I have 1, 2 I touch. This one right here, so I touch the one here and I touch the one here. But the one right here, so only other one if I touch. So these are what my trapezoids look like. So I have 1 trapezoid here, my parallel sides. So I have 1 trapezoid, 2 trapezoid, 3 trapezoids. All right. Now, what I'm saying to you is, let me read it. The trapezoid rule overestimates a curve that is concave up, but it underestimates a curve or the function that concaves down. So when it concaves up, like so, it underestimates it. See here, concave up, it underestimates it. Can anybody tell me why you think it underestimates it? Are you hearing me?
Yeah, hearing you, sir.
Tell me why I think it underestimates it.
Based on the diagram, it's an underestimate. Well, I'm not sure, sir. I'm not sure.
Look at it and think about it. Look at it and think about it.
Oh, because well, it not touching the
I hearing you. 1 minute.
curve.
I come in, Papa. Yes, Maurice. Sorry about that. A call came in. Um, talk to me now, Maurice. You're saying what?
Yes, sir. I'm saying it because it don't get to the top or the peak of the curve there.
Very good. So this is not difficult.
Yeah, true.
Yeah, man. So just look at it and you'll see it. So right up in here, so you see this gap right here, so it means that we are underestimating it. All right, let me ask you a question because what I find is when I link this thing to the real world, I want to see it much better.
Yes, sir.
Um.
That helped me too.
Um. I'm wanting it to be honest with me, frank and open. Here's my question to you. Anybody have a good friend? One bona fide. It could be a male, it could be a female, no matter to me. Anybody have a bona fide? Talk to me now.
Yes, sir.
Yes, sir.
All right, good. All right. So roll on then. So you have a bona fide. Now, say for example, your bona fide call you and say, Maurice, you're the plan. I want buying one to you. You need to pay a bill. The man them reach out. The man them me just get a call while I go see them that you have to cut off the light. Can pay a bill for me? You say, all right. How much money for the bill? $5,000. $5,300. You say, all right, hold on, I go pay it online now. I go use my credit card and pay it now, yeah? So it will go reflect same time. I say, yeah, man. Open deal, because I go install them and tell them so they something pay, and then, you say, all right, no problem. Give me a minute. And you back out the device and you pay the bill and say, brethren, the bill pay now. Him say, thanks, brethren. And him say to the man them who come back out and say, so the bill pay? Yeah, man, the man did upon him we pay the bill and him just get through a while ago and the bill pay. And because it uploads immediately, they can check to see that the bill is paid, and it saves the man from cutting off him light. Now, this is your brethren. And your brethren come and your brethren give you $5,000. You say, boy, say, me never have no money for pay the light bill and I just hustle $5,000. Maurice, let me ask you, you don't go back to him and say, hey, you remember you owe me $300 on the light bill?
No, sir. May I tell him that good man?
You're a good youth. You're a good youth. And in another situation, you have to pass your bridging yard before you reach your yard. And bridging say, yo, how far I reach? You know, say, let's stop off at KFC for buy one food, you know, and say, John, no, Bridget, you can get something for me? Him say, what you want? He said, boy, I don't know, you know, just pick up something. He said, all right, no problem, man. And you know your Bridget, because you know your Bridget eat. Or citrin, you know, your citrin eat. When you drop out the food, they're going to say, oi, hey, and a matter of fact, KFC, no eat no cheap again here. We go to the other day and you'll walk out. Not cheap again. But you go there and you spend $1,350 for buy a 2-piece chicken. When you drop out the chicken, you go to the Bridget, oh, I want $1,250 owe me? Yes or no?
Yes, sir.
No, all right, good. All right. And I ask a question because there will come a time when the Bridget said to you, oi, guess what? You know, say, me get a roast, you know, and you've always been a good friend to me. All this. He said, what this for? Bridget, let's follow something, man. Go and go buy a juice for yourself. And the brother might give you a $2,000. And the $2,000 can cover the $1,350 where they buy the chicken for, and they'll cover the $300 where you spend for pay the light bill the other time. So you got all your brethren some change, but the brethren say your plan, you're good to me, yeah, man. Go and go buy a lunch here. Me get a little money, me get a little change from the little work the roast I do. Go and go buy your food for yourself. You're my real G. What I'm saying to you is that sometimes you will win, sometimes you will lose. In this case here, this brethren is losing money because in brethren in a one bind, and it might help out in brethren right there. So I'm gonna lose. This is underestimating. But what should happen now? Let's look on the side there now. Your brethren may say, yo, you fly out, me I'll give you $100. More you buy one pack of undershirt for me and one pack of underpants for me.
Sir,
Yo.
you chip out a while ago. You said this is and
okay.
Coming back and the pack of underpants.
Oh, up here, sir, is an underestimation. And down here, so me saying to you now, you go foreign and your brethren say, see your money here. Say your brethren give you $50 and say, do me a favor. Just buy a pack of underpants for me and a pack of undershirt. And if you can get 2 socks, you can get 2 socks too. And you go to the place and the $50 would have covered the money, you know, cover the purchase of the stuff, you know. But you go on place and them say, buy 2, you get 1 free, but you buy 1 for yourself. So you get 1 free. You think your person come back and say, hey, you know, give me the receipt, I'm going to say, go on with the $50. Yes or no?
What I like him, I say go on with $50.
Yeah, go on with the $50. Yeah, man. So right there, so now, it's a little money you gain. You may get out of the $50, you may earn a little $8 change, because an $8 change come out of that time and say, you know what? I'm going to stop off a Starbucks and buy 1 drink for $4. And when you reach the airport and I come in and the flight delay, you say, you know, I'm going to stop at Starbucks again and buy something for $8. When you come back and say, brethren, you know, so I carry back $8 change for you, but me there Starbucks because the flight delayed, and the brethren go say, so where you tell me that for? Move from here, so man. That me tell my brethren, move from here, so. Don't come say nothing to me. You understand? So, right here, so your brethren owe you. But in another situation, your brethren give you money for buy a lunch. And you say, brethren, I don't want to change, or you carry the change. I'm going to slap you the change. So right here, so you catch back a little bit of the money where in the owe from up here, so. And right in here, so, him asked you to buy a lunch the other day. You catch back the money. So Monday, him asked you to buy a lunch, and him short you $500. But Tuesday, the lunch him want, you get back a $100 change, and him said, so hold on that. And then Wednesday, you get back one $300 change. So out of the $500, you get back $400. Right? So this is what it is talking about. The trapezoidal rule. When you underestimate in one instant, in another instant, you're going to overestimate, and that underestimation and overestimation going to supposed to squeeze out. And if it don't squeeze out, it comes very close to the actual, because that's why it's called approximation. Where's the word? Is much more accurate way to approximate the area beneath, right? And this is one of the things, as a math person, I always say, I use this thing to talk about life, how life is. If me have a friend who if a friend said to me, yo, go pick up something, give me the receipt, no? And me have one or two people like that, you know. One sister in one time, older person said to me, brethren, you pass the supermarket and I come and say, yeah man, you can buy a bottle of Catherine Peak water for me. I say, sure. Not a problem. But when I buy the Catherine Peak water, it come to like, then the days I make me about $450 and some or $51 and some small change. Now, what my friend did do is pay me sometimes the man like give me coins and something $450 and then I may say a $2 inside here. Since them can't give me the $1.50 something cent, them give me $2. And you know what I do? I take the $450 and take back them $2 and drop it in the man and says, alright, I don't need it. Because if you are going to be exact with me, you're going to have a problem. Because if they want to call me one day to do something else to you, I'm going to go on and tell you something I can't do it. This is how the trapezoidal rule survives. It is not exact with his friends. Trapezoidal say, when I lose right or so, I'm going to gain back right or so. Trapezoidal now come back and say, oi, you did owe me up here so when it underestimate it. Trapezoidal went and said, Pedro, school man, bring me up on my feet again. You will do something for me, I can keep the change. And I saw the trapezoidal rule squits out. And sometimes when you're using the trapezoidal rule as an approximation, when you do the actual calculation of your integration comes out to be exact as an approximation, because the method works if you are doing something that is exact. Depending on the function, you may get something that is very close. So you actually get your answer very close to the actual answer. All right. I think I've gone through that explanation. Now, there's another thing that I want to talk about. How many trapezoids are you seeing right here?
3.
So I can say to you that you have 3 trapezoids. You have 3 trapezoids. 1, 2, 3. Everybody can see that we have 3 trapezoids. 3 trapezoids. You have 1 trapezoid here, you have another trapezoid here, and you have another trapezoid here. So you have 3 trapezoids. All right, watch me. So because I have 3 trapezoids, it means that I'm going to have 4 terms. Watch the 3 trapezoids now. 1, 2, 3. Look at my 4 terms. This one here, this one here, this one here, and this one right here. So how many of them inside here? So I touched more than once.
Just the 2 inner ones.
See right here, so only them 2 inner ones here. Only them 2 inner ones here touch. The 2 end ones them now touch, so them just have no 2 right there. So, all right. Now, what I have this as is that this is an ordinal. You know, when they come to my ordinals, it's a 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th, so forth and so on. You have those as ordinals. So I have 4 ordinals here. This is an ordinal. This is an ordinal. This is an ordinal. This is an ordinal. Hear me out. I have 1 more ordinal than I have trapezoids. I have 1 more ordinal than I have trapezoids. So if I have 3 trapezoids, how many ordinals do I have?
4, sir.
Good. If I have 5 ordinal, if I have 5 trapezoids, how many ordinals I have?
6.
If I have 9 ordinals, how many trapezoids I have?
8, sir.
Aha, somebody got tricked. I have 9 ordinals. How many trapezoids I have?
8, sir.
8.
Right. 8. Very good. I heard the trick a while ago. All right, very good. All right, very good, very important, very, very important. All right, hold on there. Something is happening. I need to hold on 1 minute. All right, good. It's a home patiently I go through that something here. Make sure so you understand it, you know. All right, so let's go. So I have 1 more ordinal than I have trapezoid every single time. So the number of ordinals will outnumber the ordinals will outnumber my trapezoids by 1. I have 1 less trapezoid than I have ordinal. It's me saying the two things the same way, but I'm just reversing it. So if I have 10 ordinals, it means that I have 9 trapezoids. If I have 100 trapezoids, it means that I will have 101 ordinals. So I have 1 more ordinal than I have trapezoids. So how you know that? Watch it. I have 1, 2, 3 trapezoids, but I have 1, 2, 3, 4 ordinals. Very important. So with that said, the only thing left for me to do now is
Sir, sorry for cutting this, sir. Say it can resemble when you put up 4
absolutely.
fingers.
You put up your 4 fingers.
Go
ahead.
When you put up the 4 fingers, you say the 3 trapezoid in the middle, which is the spaces between the finger, and then the 4 fingers itself are the ordinals.
Right. So let us count the edges. The finger on the outside, the side on the outside of the first finger, of the index finger, plus that is 1, plus the shared piece 2, plus the other shared piece 3, plus the 1, 4, and then the last one out there's a 5. So you have 4 fingers but 5 ordinals. So it works every single time. Every single time it works. I promise you, it works every single time. All right. So just remember, I have 1 more ordinal than I have trapezoid. So the number of ordinals bigger than the number of trapezoids every single time. Watch me. Let us work this example. Use a trapezoidal rule to estimate that ugly something here. But it's a n equal 3. N is the number of trapezoids. So it is telling that n is equal to 3. I have 3 trapezoids. I have 3 trapezoids. N is equal to 3. Okay, the formula says it's going to be b minus a, b minus a, b minus a over n. B minus a over n. B is the upper limit, a is the lower limit, n is the number of trapezoids. N is the number of trapezoids. So what is happening here is b minus a, 2 minus 1, because there's the lower one is a minus sign. But you always have a minus sign separating the middle. So when the lower one is a minus sign, you have 2 minus signs coming together. So it's going to be 2 minus 1. And 2 minus 1 is going to give you 2 plus 1. And 2 plus 1 equals 3. And when you have a 3 there, you're going to have 3 over 3, and it's going to be equals to 1. So my delta x is going to be 1. My delta x is going to be 1. Now what that delta x does, it tells me how many trapezoids I have. All right? Hold on 1 minute, please.
So you gonna ask something?
Thinking that second off you.
Yeah, Rashim. Rashim.
Yo.
Yeah, are you off the WhatsApp group?
Yeah, me just text Alton and tell him to send me a message. Cause I can't go on the phone anymore.
All right.
I send him a number, make him thing there. Or me just
right.
make you yeah, me I send him my number, make him WhatsApp me, and me I make you admin too.
I'm Alton, you know.
Oh.
Yeah.
All right, boss. Give me a minute.
All right.
When you get a love letter calls, you must mute yourself here. All right. All right. So you're back with me now, guys.
Yes, sir.
All right. Cool. All right. No. So this not hard, you know, and I'm taking my own little time to go through the explanation because I want to know the explanation. It's not hard. It's not hard. Let me show you what I want to do for me now. So when let me give you the rule. And them say the rule is this. The integral of 2, and you have as your upper limit, and you have your lower limit as -1. Your lower limit as -1. What you're going to have is, and they tell you also that the number of trapezoid is 3. N is equals to 3. N is the number of trapezoids. Right? If they say to you that it had 4 ordinals, you can write n equals 3 because you don't have a formula for ordinals. You only have a formula for. Go ahead.
Hold on, you're using the cursor to point to.
Right here, sir. Right here, sir.
No,
I don't know if you
we're not seeing the cursor or the pointer then.
You see the cursor now?
Yeah.
Right. So this is the original question. This is a question. Oh dear. Are you seeing it now? Still?
Yeah, seeing it
Yeah.
now.
Right. So this is what I'm referencing, the original question. So what I'm saying to you is, when you look at the question, there are several things you need to look at. Sometimes I don't tell you that n is equals to 3, because the question will say use the trapezoidal rule to estimate bam 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 with 4 ordinals. But you know that you have 4 ordinals. The number of ordinals is 1 more than the number of trapezoids. So you know you can write down the value of n equals 3, because you are going to need n equals 3. You don't have a formula for ordinals. You only have a formula for trapezoid, number of trapezoids. So the formula here talking about delta x is going to be b minus a over n. You don't have nothing with b minus a over o. It's b minus a over n. So if they give you the ordinals, you must evaluate or decipher how many ordinals we have. Just remember, the number of ordinals is 1 more than the number of trapezoids. All right? So now, having done 2 minus 1 over the number of trapezoids, which is 3, see how it right here is 2 minus 1 is going to be 3. All right? Because these 2 negative signs being multiplied together will give me a positive sign. So I'm going to have 2 plus 1 is 3, and 3 over 3 is equals to 1. So I'm now evaluating my ordinals. Remember now, this delta x tells me the width of the trapezoid. It tells me the width of the trapezoid. How wide the trapezoid is supposed to be. And each trapezoid has to be equidistant from each other, meaning equal distant from each other. So each trapezoid is equidistant. Each trapezoid is equidistant. All right? So what it's saying to me is that I must start with my lower limit, which is -1, and each spacing that I'm going to go up to will go up by 1. Why 1, sir? Because my delta x evaluated to be 1. So I have to do this now in order to write down my ordinals. So it means that I'm counting by 1. So when I finish all of this, I better get 4 terms, because if I'm looking at my ordinals, it means I must have one more term than my trapezoids. All right. So if I'm starting at n equals -1, sorry, if I'm starting at -1, -1 plus 1 is 0, plus 1 is 1, plus 1 is 2. So you see here, I stop at 2. There is no way I can pass my endpoint. So one may ask, what's the purpose of doing the ordinals then, sir? Very good question. I know my lower limit is -1 and my upper limit is 2. See the lower limit -1 right here, so this is my -1, and see my upper limit here too. But I need to know how many spacings now I must have inside of this something in here. I must have number on the spacings that I have inside here in order for me to do the calculation. Very important. All right, so watch me now. So this is a function, x cubed minus 3. See here, sir? X cubed minus 3. So what I'm doing now is, in this x cubed minus 3, all I'm doing is substituting each of these ordinals inside them. That's all I'm doing. See? Substitute the ordinals into the function. So anywhere in the function I see x, I'm going to substitute each ordinal. So I'm going to do this calculation 4 times. I'm doing this calculation 4 times. Watch me. F of -1. So why -1? Because I'm starting here. So first, I'm starting here. I'm starting at my -1. So f of -1 is going to be, anywhere in the function I see x, I'm going to put -1. Anywhere in the function I see x, I'm going to put -1. Watch me. -1 squares is +1. +1 minus 2, minus 3 is -2. So the answer here is -2. Then I finish with +1. I'm going to move to 0. 0 squares minus 3 is -3. Then I move to +1. 1 squares is 1. 1 minus 3 is -2. But so you get -2 here, so I get -2 again. It don't matter. Doesn't matter. And then I'm going to move to 2. 2 squares is 4. 4 minus 1. 4 minus 3 is equals to 1. All right? So you're going to have your values. You're going to have your values right here. All that you need to do now is to substitute it into this formula. The first ordinal, remember the first one, which is a lower limit, will just be standing by itself. This negative 2, see it right here, so negative 2. But the one that is beside the negative 2 is a 0. It's going to be multiplied by 2. So it's going to be 2 times negative 3. See here? 2 times negative 3. So is the other one. It's going to be 2 times this negative 2. See here? 2 times negative 2. But the last one is going to be standing alone because it don't share the base with anybody else because it's an endpoint. So there's no multiply by 2 with this one. There's no multiplication by 2 with this one. And all we do is say negative 2, we'll write it back. 2 times negative 3 is negative 6. 2 times negative 2 is negative 4 plus 1. Negative 2 plus minus 6 is negative 8. Negative 8 minus that is negative 12. And negative 12 plus 1 is negative 11. And negative 11 multiplied by 1 over 2 is going to be negative 11 over 2. So this is going to be my answer. Negative 11 over 2 unit squares. Right? Because remember now we know. Oh, I get the half right there, so? Because this delta x is going to be over 2. Every time, sir? Yes. The delta x is going to be over 2 every single time. We get the value of delta x, which is 1, and we're going to put 1 over 2. Every single time, we're putting it over 2. All right? So that is how we do this. Oh, let me just do this and then give you a chance to go through it and look at it on your, by yourself. Oh, dear. How many? Okay. So when I do the actual calculation, when I do the actual integration, look at the actual integration. My actual integration is when I add 1 to the power divided by the new power. So x cubed, sorry, this was x squared. See here, x squared. So I'm adding 1 to the power, so it becomes x cubed divided by 3. I add 1 to the power divided by the new power. So I'm going to have negative 3, and I'm adding an x. So I'm going to get negative 3x. So this is it. When I substitute my upper limit minus my lower limit, it means anywhere in the function I see x, I'm substituting my upper limit. 2 to the third power over 3 minus 3 times 2 is what it is that I'm doing here. Minus now the lower limit. The lower limit is substituting the lower value into the said function. Negative 1 cubed over 3 minus 3 times negative 1. I'm going to have that there. What I'm going to have next is just an evaluation of the function. Just an evaluation of the function. Evaluation of the function. What is a function? The function is going to be now me working out this portion minus this portion. And when I do all of that, you can do this a little later on in class today. I'm going to get negative 6. So the actual calculation gives me negative 6. The actual calculation gives me negative 6. But when I do the approximation, I'm getting negative 5.5. So the approximation is saying to me that I'm off by 0.5. It is saying to me that I'm off by just 0.5. And being off by 0.5 is a good thing. Right? Remember approximation. So if I'm off by 0.5, I'm not off by a whole lot. So it's not a bad thing. So what I want you to do for me now, well, I kind of raise my voice a little bit-ish. What I want you to do for me is to look at this. I'm projecting everything one shot. And I want you to look at that and try and understand what is happening there. If you don't, you can stop me and you can come in and ask me how me get something. But look at that for me, please. I give you 10 minutes. Start.
Sir,
Yes, Papa.
before you go, the part where you do the actual calculation, you said that you add a negative, sorry, you said that you add 1 to the power and then you add x to the 3. How and why?
No man, that is when I'm doing the actual integration, but I don't want to look at the actual integration yet.
Okay.
Right. I don't want to look at the actual integration yet. I just want to focus on the trapezoidal stuff. No, I will speak about the actual integration sometime later. So just look at what it is that I have on the board here, on the screen here, about the trapezoidal stuff, and just see if you can understand this method. That's my aim for today. All right, start from me, please. Make sure you guys are working, you know. I don't want anybody to take any break. Make sure you're working. How is it going? Are you comfortable with it? Any questions, concerns, hiccups?
Sir, 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 your audio sound away.
Yeah, that's all right. Is it better now?
No, no, break it very choppy, breaking up.
Okay. Is it better now?
Yeah, sound better now.
All right, cool. I'm in commute, that's why.
Oh, okay. Think of follow it so far, no, sir.
Very nice. What about the rest of you? Alton, how you stay? Rashim, how you stay?
Yes, sir. I follow it so far. I understand it so far.
All right, good. That's what I want
I'm
here.
on board, on board, on board.
That's what I want here. All right, now, um,
Oh, sir, one thing.
uh-huh.
The delta, you said delta is always equal to over 2, right? So at the top, I'm going to say 2 minus minus 1. That was the upper limit minus the lower limit, not so?
Mm-hmm.
All right, cool. All right, I'm good then.
All right, no, I'm projecting example two to you. No, I don't want anybody to rant and rave. We have spent enough time with our differentiation and our integration. Now, what I want you to do for me is to look at this one. It says use trapezoidal rule to estimate the function d of x over x, upper limit 3, lower limit 1. D of x over x is the same thing as 1 over x dx. It says it has 6 ordinals. How many trapezoids does this one have?
5.
Very good.
Wait. Yeah, 5.
Right. So what it is that you're going to be doing is going to be your b minus a over 5. So it's going to be 3 minus 1 over 5. And 3 minus 1 is 2. So what is going to happen is that your delta x is going to be 2 in this case. 2 over 5, sorry, in this case. Your delta x is going to be 2 over 5 in this case. All right? Why am I pointing this out to you? Because you don't expect your delta to be a whole number in all cases like it was in the first example we're doing. All right? So what I want you to do is to look at that question, write out the question, just write the function, and then I am going to project back the example I had up top so you can follow it to see if you can carry the question as far as you possibly can. All right? So just remember, the integral of dx over x, upper limit is 3, lower limit 1. It has 6 ordinals. The number of ordinals equals 1 more than the number of trapezoids. So you're going to be having 5 trapezoids. So I'm projecting what it is that we started off with, so you can use that as a guide. Try as best as possible to go to the end.
Sir, hold on, I never write off the question yet.
Upper limit 3, lower limit 1, the integral of d of x over x, it's d of x over x. And d of x over x is the same thing as 1 over x dx. So the function is 1 over x. That's the point I'm making. The function is 1 over x. All right?
All right, sir.
Cool.
All right.
Don't disappoint, I know.
I try my best.
That question was 5 trapezoids, right?
Yeah, 5 trapezoids. Yeah, 6 ordinals. 5 trapezoids,
Okay.
yeah.
All right. Thanks.
Oh, stay.
Get in there, sir. Get in there.
Very nice. Maurice and Rashim. Very nice, Alton.
Yes, sir. Midway. About midway.
All right, keep it up.
I have my calculator with me, sir. So I have to run it in a decimal, but I still understand what's going on.
All right, cool. I'm checking my device. Are you hearing me?
Yes, sir.
Yes, sir.
Sir. Reach a part and the thing was stuck. I think I'm mixing up the thing both ordinals and trapezoids. Sir, well, you're breaking up. But sir, you'll make out what you're saying.
Sir, how many trapezoid you use? But sir, yeah, break up bad.
So it's supposed to be 5, right? 5. All right. Wait, all right. You see the part with this example that say the ordinals are, and then you get 4 digits there, because I'm supposed to be getting 6, right? For this question here. I don't know. I'm not getting those 6. I think something. I'm not sure what I'm gonna do here. So
If you're not getting the 6, after you find your delta x, right? Your first ordinal would be your lower bound, and then you keep adding the delta x to that until it take you to your upper bound, which should give you 6 figures.
oh, hold on. Yes, I keep adding delta x.
Yes, the figure you get for your delta x, you keep adding that. So you add that to your lower bound. So your first ordinal will be a lower bound. Your second one, you add the delta x to your first ordinal. That will give you your second ordinal. And you keep adding that to the answer to the reach your upper bound.
Yeah. I never realized that. All right, thank you. Sure, we hearing some, but we're not sure. Sure, can't understand.
Sir, yeah, break up, you know, sir. Yeah, break up bad. Two, say, 2, 4. That's something else. That's most of something else. Sir, we are look on the screen in about, yeah, break up, man. Sir, yeah, break up bad. Everybody else clear except you. Sir, if you just go and watch the chat, I'm going to communicate via the chat. So if you watch the chat and watch the screen at the same time.
Cool.
All right, cool.
Sir, give me a few. Let me just go through this.
I'm actually right there, so just calculating the final figure. See what it says.
All right, so I am right here, sir. But it's because, as I tell you, I work it with decimals because I don't have my calculator. Um, we get a figure what I'm not sure of. I'm right below. I'm right below the interval lengths. After that work, no, sorry. The last equation we have was the fx3 equal 1/3, which is equal to 1/3 again. I'm pass that. Somewhere below that.
I'm not following exactly where you are. Where are you seeing my point?
Yeah, may I see the screen? Oh, I'm saying we can. Oh, yeah. All right. 1 point. Hold on. You have 1.1. Yes. Hold on a sec. Hold on. Let me double check about that. Me get 1.1177. 1.177. All right. My answer kind of close to where you have, sir. You have 1.110. Me have 1.177.
The only way I get to sir get since I use decimal, you have to use all the figures you get in the decimal. Okay.
Have you used what?
All of the figures that you're getting in the decimal, if you leave out any, it take a little bit off.
Yeah, I me realize because everything me run through decimal and cause me I look at what sir have decimal and I basically that me do have before what name there? Before sir reach at the final unit. Me have 5 point something before sir reach at the final unit. So I throw it off just a little bit.
Okay.
Yeah. Alright, so that means I'm not the garbage. Alright, cool. Ah.
All right, the part that say this will result to change of x over 2. Hello?
So this is just the interval. This is the interval for the trapezoid.
Sure,
You
we
hear
never
me?
get that.
No man, right. So if you remember, no, it's always b minus a over the number of trapezoids. So b is 3, a is 1, so then your 3 minus 1 is
Sure, I
2 over the number of trapezoids.
understand. No, I hear
Hold
you
on,
good.
but are you hearing me though?
No, I hear you good, sir.
We are hearing about not so clearly. Lay it down back, lay it up again.
I'm actually speaking now, so let me try it again. What I'm saying to you is the formula says b minus a over the number of trapezoids.
Sir, we can tell you're talking, but we can't
Sir,
understand.
sir, mute your mic a little. Let me see if I can hear what you say, if I can assist. Maurice, you were saying?
Yeah, the part about this will result in change of x or delta x over 2, and then it's a hold on, 2 over 5. Yeah, all right, that part kind of lost me. The 2 over 5 and then times are off.
Times are off.
Yeah, times 1 over 2 then.
No, man, it's not a times 1 over 2 now. Delta R, you're going to find delta x, right? And finding delta x is your upper bound minus your lower bound divided by the number of trapezoids. So in this case, it is giving you 2 over 5, right? You hear me?
Oh,
Yeah,
yeah,
it's
sorry.
giving you yeah, so delta x is giving you 2 over 5. That is your, that is delta x. But the formula asks for delta x divided by 2. You understand?
Okay. Hold on. Oh,
You follow?
as in, hold on.
All right. You have your calculator?
Yeah.
All right. So you get your delta x, which is 2 over 5, right?
Oh, wait, hold on. Me just look on this comment was ceramic. So I'm saying that the is the same by multiplying by a half
Yeah.
to put it over 2. Okay. Okay.
So where you at exactly?
Yeah, man, right there, so.
Why exactly I show you off? Let me see if we can figure out what exactly I show you. So you get the delta x already, right? The delta x. Correct?
Yeah.
Yeah. So what you're trying to find out is what? The ordinals?
No, man. I just that part there. I get what Sarah saying, but it's still, I don't know, it's still like me not connect with this at all.
So you find the delta x, which is 2 over 5, right?
Yeah, man.
If you get your ordinals, so you start with the lower bound, which is 1, right? If you get the second ordinal, you're going to add that figure of your delta x to the 1. Right, so it's 1 plus that figure you get for your delta x. That is going to give you a second ordinal, which is 7 over 5. And then the 7 over 5, you add the delta x again to it, which is the 2. So it's now 7 over 5 plus 2 over 5, you get 9 over 5. Right, so you keep adding that delta x until you reach your combo, which gives you 6 ordinals.
Hold on, let me just do a little calculation.
Yeah, look at the screen, Maurice.
Yeah, yeah. So the last thing, sir, say about dividing. Yeah, really just to divide by 2. That really threw me off. So one more thing. The guy we're talking about the intervals. Because it says the 1 plus it would be the what else?
You mean the ordinals? All right. So remember the ordinals are what you're going to substitute into the function. So you find the ordinals and then you substitute them into the function.
Hold on, before you go there, so the all right. The interval lengths are as follows on it. You have the 1 to the 3. So we keep adding, you were saying we keep adding is the 1 over 5.
You're adding? No. The 1 over 5 wouldn't come in until you're going to in there the function. After you find after you substitute the ordinals into the function and you get the answer for all 6 ordinals, then so the 1 over 5 come in.
Hold on, sorry, the 2 over 5 you keep adding.
Yes, to get the ordinals.
Yeah, that may realize. All right.
Yeah.
Only the parts in there mix me up.
Okay. So after you do that and you get your ordinals and you substitute the ordinals into the function, then the 1 over 5 comes in the main function, the main formula.
Sorry, repeat that again.
I'm saying after you get the ordinals, right? You start with your 1, and it's the 1 plus the 2 over 5, which is 7 over 5. Then you add 2 over 5 to that, and you get all your ordinals. Then you're going to substitute those ordinals into the function.
Yeah.
Right? So that's how you get your 1, your 10 over 7, your 10 over 9, your 10 over 11, and such. After that, now, when you're fixing up the main formula, that is when the 1 over 5 is going to come into play. Because 1 over 5 is going to multiply everything in the parentheses.
Oh, yes. Yeah, miss what you're saying now.
So you use delta x to get the ordinals. But when you get the ordinals and you substitute those in the function, then you're going to use a delta x divided by 2 in the main formula.
Right.
So the delta x divided by 2 is what gives you the 1 over 5.
Right.
Yeah.
Right. Okay. Come on, no first speak.
All right. So are you understanding it now, Maurice?
Yes, sir.
Yeah, man. So what I think if you could get a natural display calculator, which is that it can actually work the functions for you.
Sir, sir, hold on. Can't understand you again.
All right.
They're saying to get a natural display calculator so it can actually work the functions for you. So when you put in a function in natural display, you can get it back as a function and not a decimal. Or you can choose whichever you want it as. The answer is.
Okay.
Yeah. Big. Yeah, on the side. Yeah, man. Very good.
Sir, one more thing. You can just scroll back up to the original question. Just want to make sure I get it done. Right.
Not a problem. So question number 2, that one?
Yeah.
Or the first question that we did?
No, this one. This one.
Okay, cool.
Okay. Yeah. All right, sir. You can move on.
All right, so let me get it from you now. So you're understanding the question fully now, right?
Yes, sir. I believe so.
Right, good job. So I'm going to find another question. Question number 3. Share that one for me. I need to see how far you can go with that. Question number 3. All right.
All right.
All right so far?
Yes, sir.
Yes, sir. I'm just calculating the final answer, sir.
Another 2 minutes. Are you guys finished now?
Not yet, no, sir. Reach near the last spot there.
No problem. Cool. Finish?
No, not done yet, you know, sir.
Take your time, take your time. I'm not rushing you. It's just I'm just excited to see if you get to this up. I see Alton's answer, but I don't want to project it yet. I want to give you an opportunity to complete it
Hold on,
before.
sir. We can't understand you again. Breaking up, bud.
All right, maybe Alton and Rashid hear me better. So I'm just saying, I've seen Alton's answer in the chat, but I don't want to project the answer just yet. So I'll be done in another couple of minutes. That's all right? So no, keep it. Huh? No, I'm having a new one. You never know that you know when things are. Alton, I'm sorry, not Alton. Before you
Sir, hold on, I have to write off those things because I go wrong for the length of the ordinals. That's where may end up go wrong. Throw me off. Well, no, sir, we're not hearing you. Good, sir.
All right, let me go to the chat.
Yeah, we're hearing you better now, you know. As I said, let's go to the chat.
Oh, all right, cool. So what I'm saying to you is that I'm going to give you one now, the exponential function, e to the x squared plus 1. This is the exponential function. I want you to try it because they can give you an exponential function or a logarithmic function. All right, so try that one with the exponential function for me and to see how well they get it. You continue writing off what it is that you need to write off. Alton and we'll hear from Machine. Machine, how far are you?
Sorry, sir. Just reach back home. Okay. I mean, that's the term, but me I follow through, see me from what you guys are saying.
Move on to example 4 for me. And then let me know.
Okay, sure.
Is that e to the x square or x cube?
E to the x cube plus 1.
Not hearing you clearly.
E to the x cube plus 1.
Oh, cube. Okay. Oh, square.
Oh, square.
Oh, square. All right, thanks.
All right.
Sir, I beg you, zoom back out a little bit. I was still taking out the question. Not the question, sorry, the answer for the previous example. All right, that's all right. No. Can zoom in back some more, sir.
What's about 100? Oi, you fine.
Yeah, that's all right.
Obviously, talk to me. Obviously.
I think says, I put the answer in the chat.
Oh, you did? Or you
Yeah.
don't? You put it in here now.
Yeah, it's just sent in there.
Sir, I'm still working it out,
That's fine. Take your time, Maurice. Take your time. I was checking into let you know that I'm here.
Why, sir? I mean, my pause still no. My pause. I can't even make it any further. Because may I look on the question?
Talk to
Hmm?
Alton, man. Alton is understanding this stuff.
Alright,
Alton?
Alton, you have to give me a walk. Give me a walk through, Alton.
All right. Most of this I just use my calculator to do it. Let me see if I can explain it. All right. So the same procedure applies where find the ordinals. And based off of the previous examples, the ordinals are the same. So it's just to apply, substitute those ordinals now into the function. So I use my calculator to work that function, e to the x squared plus 1. So, wherever x is, you just put your the ordinals for each one. But in this one, it's pure decimals I'm getting, so you have to write out a lot of.
Yeah, but watch now.
Mhm.
You have the equation and then say on the interval 0, 3. Is it that 0 is the lower limit and 3 is the higher limit?
Yes.
All right, so now, right? The e raised to x squared plus 1. You never differentiate that, or did you?
No, I didn't do a differentiate. I didn't differentiate.
We never ever differentiate anything.
Mm-hmm.
When we're doing the trapezoidal rule, we're not differentiating, we're not integrating, we're only substituting after we find the ordinals,
Mm-hmm.
we're substituting the ordinals into the function. No differentiation, no integration.
Right. See, it's when e combinate, boy, just so many time it get me confused.
Do you have the thing, the calculator?
Yeah, man.
You have. So you can actually put in that function in the calculator,
Yeah, man, I know, but some of the time the thing is that it's when the letter E just appear in the function. You kind of have wicked.
Yeah, but if you already have it on the calculator, you don't need to worry. It's just putting the function in the calculator.
Mm-hmm. Right.
So remember the main point there, from you find your ordinals, you just substitute the ordinals in that function.
Alright, we'll try so we can work this properly now then.
All right, so.
That's 0.5. Respect.
Yeah, man, no problem. Oh, yes, Steve Morris, I get it.
Yeah, I get it, I get the whole heap of decimal them you say.
All right.
Hold on then. Alton.
Yeah.
All right. So what you know? This is how I treat me, So it's a 5 trapezoid, right?
Mm-hmm.
And it should be 6 ordinal if it's 5 trapezoid, because ordinal is 1 over.
Yeah.
Because so and work it out. So
Mm-hmm.
say it's the high minus the low over the ordinals, which is
No,
3
over the
minus
number.
low
No, over the trapezoid, not the ordinal.
over trapezoid. So we
Yeah.
let me see how many use it.
Very good, Alton. It's not the ordinals, and it's over n.
Yes, it's
It's
over
over
n.
above
Yeah.
N.
trapezoid.
Over
Right, it's
trapezoid.
above trapezoid. Right.
Yeah.
Very good, Alton.
Alright. I mean, I wonder how comes me I get 7 something down here instead of the 6. Alright.
No,
Fire.
remember, no. If the question tells you that it is 5 trapezoids. So when you get in your ordinals, you start with the lower bound, and then what you get for delta x, you
Yeah,
add that
add it
to
to
your yeah. So you should get 6. So when you reach your when you stop.
1.2 1.8. C6 there. Alright, we're Gucci.
All right, no problem.
Yeah? Yes, sir. Me almost finished. Mm-hmm. All right, cool. All right, done. Let me see. Bam, bam, bam. Alton,
Yeah, well, man.
you know quite done yet, you know, me G. You know,
Eh?
you know quite done yet, you know.
You're not quite done yet?
No, you not quite done yet, because the question said to go to the third decimal place, no?
All right. Oh, let me check. Oh, oh, and it's when I was the father. All right.
All right, my boss.
Yeah, thanks.
Hey, tell me something. The 7,000 that are the answer, right?
Yeah, man, 7,107. Sorry, 7,177.207.
Oh, sir, gone.
So drop
Me
off.
no, me no, me go wrong somewhere, no. Me go wrong somewhere.
Where you go wrong?
Me no know. 2,000 had me get.
The 2,000 odd way you get is 2,039. No, that wouldn't be 230. No, should have been 22,
I
23,
get
24.
2,431 some decimal place.
Where you get for your first
Um,
interval?
the 0,
Yeah, where you get for the 0?
a 0 again.
No, man.
When we
All
put
right.
it,
So sorry about that. I lost connectivity on one device. I had to sign into another.
unless I put it on my calculator wrong.
Maybe, cause yeah, man. So we realize you drop off. Cause what is that, you know, the e raised to the power x, and then the x there raised to the power 2, then you come back down to the x level plus 1. So maybe you put it the plus 1 beside that, the raised 2, maybe.
all right. Do me a favor. Do me a favor.
Try that again.
So when you press the exponential function, open your parentheses first before you do anything else. So e, open your parentheses, e raised to, open your parentheses, then you put in an x squared value plus 1, close the parentheses. I think that's the problem.
All right, hold on, sir. No, are they a -1?
No, man,
Minus 1
plus 1.
Plus 1, plus 1.
plus 1.
Rotted. For me, like, I guess because I already something did fine, I never see it look like a minus.
Oh,
Got that. All right.
All right, you know what I'm going to do? Something that came to mind. I think you three guys worked very well together today. Congratulations. I like the teamwork. I like what it is that I experienced today in class. I'm going to send off, of course, the same recording again as per usual, to the channel. I'm going to see if I can generate some questions, and drop in the group. And I want you guys to work on it and having a conversation, just like we have the conversations in class just now. Have the conversations about it in the WhatsApp group. I will be there to see what is happening. But I think it was a job well done for today. Congrats. I really hope that you guys can be successful in the exam to come. Really, a real good effort was made in class today. I'm very pleased. Thanks again.
Welcome, sir.
Thank you too, sir.
All right, cool. Best up. We'll talk here.
all right, cool. I'll tell me other to your group right now.
All right, cool. Thanks.
Yeah, man.
Yo, no mind not leaving it till me just work back out this. Just want to make sure me get it right.
Yeah, man. What we can do still is, you know, what time I'm available Monday, if it is that you want thing there. Work on the Edicasa.
Yes, definitely. Me can't say what time yet, but for me, the earlier the better still, you know. Cause I know I go have some other group coursework I deal with. Sure of that.
All right, we can figure out something by now on Monday.
All right. Hey, when you find the them value, how much decimal place you use?
Always use one above. So if them say them want 3 decimal place, you use 1 or 2 above it. So you go about 3, 4 or 5 decimal places. But use 1 above the required.
All right.
They use the exact 3, you're gonna get messed up. And then when you're done now, you round it off to the 3 what them want. I'll tell me I did a while ago. I'll tell so like in there.
Are you still there?
Yeah, man, we're there,
Yeah.
man. We just help out Marcus. Maurice, sorry.
Maurice.
Yeah. But what I say,
Change my name, star.
what would I say? If you don't want jump on one call Monday, or run
Monday?
through some we'll run through some etiquette stuff.
Yeah, we should be able to do that. But what time?
Maurice have to tell you that because him say him mainly free in idea part. But me not 100 sure about that because
No,
by
tell me,
around.
all right, whatever good for the majority, you know, me have to go work with that, you know.
Like how we are going to the WhatsApp group, we can just confirm what time and stuff, you know? I'm going to tell myself available.
Me just make you know the time when I'm available Monday because me I come in from fishing early in the morning and then then have a meeting with my name the Reverus and then carry my girlfriend go work.
Okay. Which one are you fishing?
I think we are go Port Royal Point.
Yeah, just short money ago, because from what they may contemplate for go. Passed through a few times, but
Sunday night we are go fishing, you know, and then come back Monday morning, you know.
oh, that sounds like a good plan. Because from what they may plan for camp out over the two.
Nice man.
Yeah. All right. Just show let me know still.
Alright, cool.
Cool.
Mm-hmm.
You add me to the group already?
Yeah man, we had a tea group, man. Yeah, see by phone it.
Oh, yeah. Let me see. All right, cool.
Lord, fire no. So it's always the chopper side. Alright, cool.
If anything, just show up my group, yeah? I'm gonna go.
Yeah man, dating.
Rashim.
Yo, yo.
For the last volley, right? When you had substitute the thing in the formula at 22,000 they get.
22,026.4658.
Alright. I want to make sure I'm on the right page, you know, because I can't go back over the whole thing again. Yeah, man. Yo, me I wonder if there is a people them if I give up or something, you know.
Why? No, you know, cause a good amount of we there in the class. I'm frightened. I join online. I'm just a 3 hours alone.
Yeah.
Frightened.
Me
It's
too.
because of my money I spend.
Exactly.
Mm-hmm.
I make me want done this, you know, want done the degree, so I have to put out some effort.
You want done the degree, you want done the exit.
Well, yeah. Yeah, ultimately that is.
Oh God. I'm done, man, because after I'm done my bachelor's now, I move on to the master's. I'm just do some certification because currently I do a web dev certification, you know. So that's not herb and done.
Yeah, man. Wala nga man. Kaya rough star.
Rough, man. Rough. All of them, yeah. Oh, which fire there?
Yeah?
Yeah, put it in the bracket down on the last part now, not so.
Yeah, man.
Okay. I remember say everything inside except for the 2 N1 them. Everything inside supposed to have 2 before it.
Yeah.
Yeah, so I just the first and the last one and a 2 before it.
Yeah. So done. Rashim, 7,000 they get, don't it?
Yeah, 7,177 and fine, whatever.
Alright, so me I get 6,000.
I get 6,000.
Yeah. I'm gonna just check them figure, make sure me
Tell me the figures that we have. Give me the last equation we have.
Alright, so the 3/10.
3/10 that come back down to 0.3, yeah? Continue.
Yeah, and then so open the bracket now. 0 plus 2, and that gonna be times 2.7183.
2.71. Well, 8-2 me have no, but continue. Where you get 8-3?
Me round up this, I think around me round up the figure.
Remember I know let me check it back. Here's 0, here's 2, come back down, that's 1. Oh, I mean if I run up mine. Hey, continue, you're good.
All right, I'm gonna get 2 times 3.0649.
That one they look wrong now.
That look
Hold on.
wrong.
So that's 0.6 raised to 2, come back over plus 1. It's supposed to be 3.8962. The 0.61 is supposed to be 3.8962.
All right, I'm gonna just write that 6.2. And that are the one with e to the 3/5 squared plus 1, right?
3/5.
Yeah.
Oh, fractions, yeah, though. I'm doing it in a decimal now. That are the second one from 0, you know.
Yeah, the second one then.
Yeah, second one from 0. 1, 2, 3, 4, 5, 6. Where you get for the third one?
3.4556.
Alright, that one is supposed to be 11. 11.4730. What
So
I think,
hold on.
what I think you have the issue is at how you do the power. That's how I think you have the issue. Because it's supposed the power raised twice right here saying so is e raised to the power of x raised to the power 2, and they come back down to the x level plus 1. So it's basically like x squared plus 1. So it's e x squared plus 1. So
Hold on. Me I wonder if I write this something wrong. So now the original question, right? When it said the f of x. Now e to the x squared plus 1.
it's e to the x squared plus 1, but the plus 1 is not in the square power, you know, it is in the x power. It's basically like you have x squared plus 1 and they put it above the e.
Oh.
So what me I think you ought to know, you have e to the x squared and they plus the 1 to the square itself instead of you plus it to x squared. That me think you plus it to the square itself.
Oh. All right, hold on. Let me try to work that on the calculator different. Hold on. So, all right, me I got in type on the calculator, right? So me I put e to the, me use the fraction. So 6/5 squared me I got
6/5 square, and then you come back down and then you put the plus 1 because the plus 1 actually a plus to the 6/5, you know, and not the square itself. It's supposed plus to the 6/1.
to the. So when me I enter that on the calculator, all right. So you already said for put in the brackets, right? So me I put the plus 1 outside of the bracket.
No, you see, me not work with the bracket now, so I'm not gonna understand when it says put it to the bracket. Yeah, I use one of them scientific calculator that normal.
Well, I don't know about I don't know the one we normally have.
Alright. Alright. So what you do now, you put in the e, right? And then now you have the power sum. Your power sum is x and a back beside that.
No, well it have this like a upside down like almost like a arrow pointing up. Not really an
Oh,
arrow.
the upside down V.
No man. Alright, you have E. You have the E.
Yeah.
E to the X. So I press that already. But then
You
put it
take
to
a
the
picture
4.
it by your phone and send it to me. Let me see if we can do a look recording for me and send that to
Alright,
you.
may I put in the what I would have put in normally. I'll make you see what I do.
Alright, cool. Alright. Alright, so you that go. Shift E. And then now we raise 0.6. We'll raise it again. Now be 2. They'll come back out. Now be plus 1. Right, so it's supposed to look. And then press equal.
Send it here.
Alright. Me just send something in our group. Let me see what you send me. Yeah, that look like it. Someone not understand.
Alright.
It's 6.5. Oh, yes, it's 6/5.
6/5.
6. 6. Let me try it that way there. Shift E. For 6/5 square plus this one. Me do what you do a while ago, me get back the 11 point something. 11 point. Add.
I'll go on this now.
But me not use me.
Let me try it without the brackets up then.
Yeah, try without the bracket. Let me see. Any yeah, me send a picture of the calculator you need. Oh, I need my G. So that cure issues. Cure
Okay.
issues. Yeah, man. That cure issues. Therefore, go on pharmacy or somewhere go buy this.
I got. Be honest with you, me I try to find a way if you make that one work, but if it no work out, I have to go buy that one. But no, I get that. You know, me have to go tackle this later, but just alright. You can just tell me the value them where they get. Because me have to go find a way for work that out. It could work.
Send the value again. Send my last part of the question.
Oh yeah, take a picture.
Yeah, that looks clear.
But a decimal place you say you use.
Yeah, decimal me use whenever I use a fraction. I can't bother work out in a fraction. No. Can't bother with that. That's stressing me out, man. When we can't see the number them line on, me feel much better. But fraction, no. Time I say I work out nothing in a fraction, me it start hurt me.
Yes, man.
It start hurt me, man. Let me see, I say, Jaja. Boy, sir, decimal, no, sir. Decimal, please, decimal. But you can look on this and thing there. Try see if we can get it. I'm gonna put the first part in it. Let me check why I'm put the first part in. Yeah, 0 minus 3 minus 0/5, which give you 6, 0.6 or 0.6, let me say.
Hold on there. Your
You see the top part where you see with 0 and 0.5 and everything with 0.5, check out that. That's not supposed to.
okay. I the one with the 0 and the 0.6 and so on.
Yeah, that's a correct one. I'm send it back. See there. I'm saying nine group as well.
Maybe I better have me just work with them in a decimal like how you do it, you know.
Can't buy that fraction. Amish. Them people not coming in class. Nesta. And make sure you stress out yourself. Can't afford a fail, you know.
That me I say, man. Yeah, I say, yo, if it even have to stress me out and carry me to the point of near insanity, me have to pause.
Why?
Give
Me
up
just
my
want
sanity
done.
later.
That's what I'm done. If I'm done, I have no more school to worry about. I can focus on business. I can focus on work. Done.
Yeah.
Mm-hmm. So you can just follow through on that.
Yeah, man.
And anyway, you fall short, you just ping me or you ping Alton. I'm there in I group.
All right, cool. No respect.
Yeah, man. Now a little bit.
Yeah.
Yeah.